Hi everyone, welcome to this video of a complete walkthrough of Edexcel AS Level Applied Mathematics, that is Paper 2 Statistics and Mechanics of summer 2018. This paper is of length 1 hour and 15 minutes and we will attempt to finish it within the time. Question 1. A company is introducing a job evaluation scheme. Points X will be awarded to each job based on the qualifications and skills needed and the level of responsibility. Pay, that is Y pounds, will be then allocated to each job according to the number of points awarded. Before the scheme is introduced, a random sample of 8 employees was taken and the linear regression equation of pay on points was y is equal to 4.5x minus 47. Describe the correlation between points and pay. So please review the information given in the question. The key points are, it's a linear regression equation and the model is y is equal to 4.5x minus 47, which means this is similar to an equation of a line y is equal to mx plus c, where m is 4.5. Correlation is actually equal to the gradient of the line. So here it is plus 4.5. Therefore, the answer for the first question will be the correlation is positive. So the correlation is positive. If at all this m was negative, we would have written the correlation is negative. Give an interpretation of the gradient of this regression line. What this means is, what do you mean by the gradient? What does it represent in this context? So we need to give an interpretation that for every point gained by an employee, his salary will go up by 4.5 pounds. So for each point gained by an employee, his pay will increase by pounds 4.5. See, explain why this model might not be appropriate for all jobs in the company. So if you review the situation here, you will understand that there could be something inappropriate. What could that be? So y is the pay, 4.5 times the points gained minus 47 is going to be the net pay. So is it possible that the net pay may be negative sometimes? So imagine this particular job role gets a points number of 10 based on its responsibility, qualifications needed, etc. In that case, this will result in 4.5 times 10, which is 45, minus 47, which will be minus 2. That means an employee will be getting a salary of negative 2 pounds, which is not appropriate. So we could say for points or for jobs getting an assignment of 10 points or even less, what will happen? The salary will be the salary of the employee will be negative. This is unrealistic. This is a 1 mark question. For every model, you can always expect a 1 mark question at the end, which will ask you to critique that model. So you need to find something plausible which you can write, something reasonable that will show that the model will not work all the time. Question 2. A factory buys 10% of its components from supplier A, 30% from supplier B, and the rest from supplier C. It's known that 6% of the components it buys are faulty. Of the components bought from supplier A, 9% are faulty, and of the components bought from supplier B, 3% are faulty. And this is overall 6% faulty. Find the percentage of components bought from supplier C that are faulty. In this question, it's better to put these details in a table such that we will know what's going on. So, right. So let's say the name of the supplier is A, B, and C. Okay, let's say this is supplier. Okay, how much do they buy from supplier A? 10% of its components. From B, 30%. from C, the rest. That means 30 plus 10, 40, and therefore this is 60%. All right. And then let's say what percentage is faulty from A? 6%, no. It's bought from supplier A, 9% are faulty. So let's put 9% here. From B, it's 3%. And from C, we don't know, and that's what we have to find out. So let's say it's X%. Let's also document here overall faulty. Overall fault percentage is 6%. Okay. So the success in our strategy is writing out an appropriate equation. If you write the equation correct, most of the problems can be sorted out easily. So what is the equation here going to be? We can say what is the overall percentage of faulty by adding all these things and putting them equal to the overall fault percentage which is on the right. So let's say 10% of 9. That means 10% of 9%, which will be 0.1 times 0.09, okay, plus 0.3 times 0.03 plus X%, that is X over 100 times 0.6 is equal to 0.06. Simplifying this, we get 0.009, add another 0.009, add, let's write this as 0.6 divided by 100 is 0.006, X is equal to 0.06. Okay, which means 0.018, add 0.006, X is equal to 0.06, which means 0.006X is equal to 0.06, take away 0.018, and that's going to be 0 minus 8, 2, 5 minus 1, 4, 0, 0 point. That means 0.006x is equal to 0.042, which leads us to 0.042 division 0.006, which is equal to 7. That means X is 7%. So let's go to the next part of the question. A component is selected at random. Explain why the event the component was bought from supplier B is not statistically independent from the event the component is faulty. So here we have to put this condition to test. The condition for independence is if there are two outcomes A and B, okay, these events will be independent only if and only if the probability of A times probability of B is equal to probability of A intersection B. So this is what we have to put to test in this context here. So the question says that the event that something is bought from supplier B, that means probability of a component being supplied by supplier B is equal to, we need to find that out. What was that probability? Wasn't it 30%? Yes. So let's write 30%, which is equal to 0.3. Okay. Then probability of something being faulty, we have been told that it is 6%, so that is equal to 0.06. The next is probability of B intersection faulty, that is supplied by B and at the same time it is faulty, and that is this second thing here, that is 0.03 times 0.3, okay, which is 0.03 times 0.3 is equal to 0.009. So that is probability of B intersection F. So now let's put this to test. What's the probability of B times probability of F? That's going to be 0.3 times 0.06 is equal to 0.018. And that's not equal to this. So probability of B intersection F is equal to 0.009. So we need to write one sentence here as probability of B times probability of F is not equal to probability of B intersection F, they are not independent. Categorically say and underline, they are not independent. Question 3. Nasir is playing a game with two friends. The game is designed to be a game of chance so that the probability of Nasir winning each game is 1/3. Nasir and his friends play the game 15 times. So this is n for us and this is the probability. Find the probability that Nasir wins exactly 2 games and more than 5 games. So we need to first of all see whether this satisfies the conditions for binomial distribution. It seems so because n is equal to 15, which is a limited one. The probability is 1/3, which is not going to change from event to event. So it is constant. And finally, it's a binary thing. That is, whether he wins or not is a yes or no question. So it is definitely a binomial distribution. So we can actually define the assumptions here. So let X be the event that Nasir wins. Event that Nasir wins. Okay. Hence, X will follow binomial distribution with a number of trials 15 and probability of winning 1/3. So the question now boils down to finding out the probability of X being equal to 2. So you need to use binomial PD. Okay. So if you put 15 in the n and 1/3 in the probability field, then you will be getting, as per the calculator, I got 0.0599. Okay, so remember to put PD here. Okay. Next one is probability of X being greater than 5. So in this case, it will be cumulative distribution under binomial distribution. Okay, so if you put the same criteria there, that is 15 for the number and 1/3 for the probability, then in the calculator we get 0.3816. So these are the two probabilities that the question is asking. He has a method to help him win more than 1/3 of the games. To test his claim, 3 of them played the game 32 times and Nasir won 16 of these games. Okay. Stating your hypothesis clearly, test Nasir's claim at 5% level of significance. Okay, so this is a hypothesis testing question, and please understand the concept very well. There is no AS level or A level statistics question paper in which a question on hypothesis testing is not there. So it's a very important concept. Okay, but it's very easy and an interesting concept as well. So what we need to do is, as per the marking scheme for Edexcel, we need to document certain very minimum things for every hypothesis question. So first and foremost, we should say, what's the null hypothesis? What is the alternate hypothesis? In this case, the null hypothesis is probability is equal to 1/3, and the null alternate hypothesis is probability is, so he's claiming that he has got a better percentage of win now. So we're going to test it. Therefore, P is greater than 1/3. Okay. Then what's the number of trials? He played 32 times and won 16 of them. So we can say n is equal to 32. Let's say X is the number of wins. He's got 16 of them. So alpha level of significance is, this is a one Taylor test. That means we are only testing one part of the hypothesis. So it's 0.05. Okay. So next very key phrase that we have to add into this answer is assuming HO to be true. What this means is, we are saying that all the conditions and assumptions with respect to null hypothesis are assumed to be true, and in such a case, what's the probability of X being greater than or equal to 16? Because he has won 16 times, we are now putting it to test whether that 16 is actually an outlier or it's part of the assumptions under null hypothesis. That's what we are going to test. So we go back to the binomial calculator now. So number is going to be 32, but the probability is still going to be the same. And we are going to test whether it is above 15 because 16 is to be included. So we have a probability that it is 0.0376. So it's 0.0376. So I would strongly recommend you to make a presentation like this. Put a rectangle here. Put the 0.05, which is our alpha value here. That's the level of significance to which we are testing this hypothesis. And here, put the probability that we just now calculated, 0.0376. So obviously, the level of significance is greater and the probability is less than that. What this actually means is, assuming the HO conditions to be true, the probability of somebody winning 16 or more is of having less probability than 0.05. But even then it happened. That means there is something wrong with the HO. So that's how the calculation as well as the concept goes. Since this is less than that, it was not supposed to happen, but it happened. Therefore, there is enough evidence to reject HO. You can say sufficient evidence to reject HO. We also need to say a contextual representation or narration about what this means. What does this mean? If you are having sufficient evidence to reject HO, what does it mean? So you can say there is evidence to support Nasir's claim. There is sufficient evidence to support Nasir's claim that his win probability, let's say winning probability, has increased. From 1/3. So why I took effort to write all these things is every bit of this is essential for you to get the full marks under this question. Question 4. Helen is studying the daily mean wind speed for Cambon using large data set from 1987. The data for 1 month are summarized in table 1 below. So wind speed is given here and frequency is also given here. So calculate the mean for these data. This is a very seemingly easy question, only 1 mark, but trust me, there are many students who get it wrong. So common student errors are just adding up all these wind speeds and dividing by the number of columns here, or just adding up the frequency and dividing the total from here. Actually, what we need to do is each one of them has to be multiplied to get the number. That is 6 times 2, 7 times 3, 8 times 2, etc. And then you have to sum it up and then divide it by the total frequency. So that's the definition for mean if it is given in a frequency table like this. So let's write this out. Mean is equal to sigma f of x divided by sigma f, where f is the frequency and x is the data for each month. And that when you multiply and add, I get 184 and the frequency is 18. That gives us 10.222, and if it is to 2 decimal places, you can say 10.22. Next part, calculate the standard deviation for this data and state the units. Okay, so standard deviation formula will be given in your formula sheet, and I can tell you standard deviation, which is actually represented by sigma, is equal to, put a big square root sign. Okay, the first part of it, actually there are 2 parts to it separated by a minus. The first part is mean of the squares. Second part is mean. Therefore, we need to square the mean. So square of the mean. So in short, it is square root of mean of squares minus square of the mean. So actually, what is the mean of the squares? So each x value is square and multiply it by the frequency and sum it up. So that's the total and divide by the frequency. Therefore, it will give you the mean of the squares. So doing so, we can actually represent this like this: sigma f of x square over sigma f, okay, minus sigma f of x over sigma f, which we already calculated. So in this case, the mean of the squares happens to be, let me put the square root sign here, 2062. That's what I got when I squared each x value and multiplied by the frequency. And when I divided by the number, frequency number, it's 18 minus this. I can just put 10.22 here and square, because we already calculated the mean. You just need to square it. So putting that into the calculator, we get 3.17. And in standard deviation, we also need to write the unit. So we are actually measuring the wind speed. So standard deviation will be also having the same unit. So you need to write knots. End of story. Next part of the question: the means and standard deviation of the daily mean wind speed for the other months from the large data set for the same city, Cambon, in 1987 are given in table below. The data are not in month order. All right. So what do we have here? Months A, B, C, D, E, 5 months. The mean is also given here. It seems to be increasing, and standard deviation is also provided here. Using your knowledge of the large data set, suggest giving a reason which month had a mean of 11.57. So here we need to have a little bit of knowledge about both the weather of UK, because Cambon is in UK, as well as what this large data set contains. So two things. One, it's quite windier in UK during the autumn months. So that's one indication that 11.57 must be towards the autumn. And secondly, the large data set contains data from May to October. So the last month which is captured in the large data set is October. So if it is, which is also the last part of the autumn, so it's sufficient if we say that E most probably refers to October. So just giving a reason which month had a mean of 11.57. So we can say, so let's make a space here for writing the answer here. It's October. Categorically write the month name October. Then you can give the reason. It's windier in autumn and October is the last month captured in large data set. You can say large data set as abbreviated LDS. The data for these months are summarized in the box plots on the opposite page. So we saw some box plots there. They are not in the month order or the same order as in table 2. D. State the meaning of the asterisk symbol on some of the box plots. Okay, so that asterisk symbol is usually denoted to outliers. So this is outlier, that's an outlier, that's why it's outside the range. So we can say here D, I, okay, asterisk symbol represents outliers. Next part of the question, suggest giving your reasons which of the months in table 2 is most likely to be summarized in the box plot marked Y. So let's have a close look of the mean of the table. So the mean here, 7.58, 8.26, 8.57, 8.57, and 11.57. So this gives you an idea. There are 3 months in which the mean is close to each other. Let's look at the 5 box plot diagrams. Okay, so y is one of the 3 having mean close to each other. Therefore, it could be either B or C or D, because this and this are out. They could be either A or E. Most probably this is E and that one is A. So now we have 3 candidates, B or C or D, and we need to figure out which one of them. All of them have similar mean. Okay, so what differentiates y between this and this? Y has got a bigger standard deviation. If there is a bigger range, so the range is always the lowest value to the highest value, including the outlier. Therefore, this has got a bigger standard deviation also, because the range and standard deviation are related to each other. So let's look at B, C or D. Which one has got the standard deviation on the higher side? So B, C, D, similar means, and B has got 3.89, 3.46 and 3.87. So B has got the largest standard deviation here. Okay, so how do we account for this mean? This is 8.26. How do we say that it must be B? We can also say, since if you add this outlier also to calculate the mean, you can see here this is close to 7 here. That will jump to more than 8 if you include the outlier. Therefore, it is definitely B, because it has got a mean which is close to 8 point something, and the standard deviation also bigger among the 3 middle B, C and D. So we can say we have to document this here in a reasonable manner so that we will get full marks here. So we can say y cannot be A or E, as y has a mean close to 2 other histograms, not histograms, box plots. Okay, so y has an outlier which justifies mean greater than 7. Y also has standard deviation higher than C and D. Hence, y must be B. So we have fully justified why we have selected B, and it's appropriate there. Question 5. A biased spinner can only land on one of the numbers 1, 2, 3 or 4. The random variable x represents the number that the spinner lands on after a single spin, and probability of x being equal to r is also equal to probability of x being equal to r plus 2 for values of r is equal to 1 and r is equal to 2. Given that probability of x is equal to 2 is 0.35, find the complete probability distribution of x. It's a 2 marker. So let's put it in a table so we'll understand the information better. So there are 4 possibilities, 1, 2, 3 and 4. And then we have to also write out the probability. So let's say okay, let's document this. Okay. So what does it say? There should be 4 columns. 1, 2, 3 and 4. Okay, and then let me put 3 rows also. Okay, so this is x is equal to r and the outcomes are 1, 2, 3, and 4. Remember, this is a biased spinner, therefore the probabilities won't be the same. The question also tells us that probability of x being equal to r is also equal to r plus 2 for the cases of 1 and 2, but not for 3 and 4, mind you. So for here, we can say x is equal to r plus 2 means 1 plus 2 is 3, 2 plus 2 is 4, and this 3 will remain as 3, and 4 will remain as 4. And the question also tells us something. What is that? Probability of x being equal to 2 is equal to 0.35. So we can put that safely here, 0.35. Okay, which means probability of 4 is equal to 0.35 means here also it is going to be 0.35. And here probability of x being equal to 3, the same here and the same here. So let's put it as x. Now it will be crystal clear to you that all the probabilities if added to 1 can help you solve for x. So we can say 2x plus 0.70, which is 0.35 plus 0.35 is equal to 1, which means 2x is equal to 0.30, which means x is equal to 0.15. Underline. Now we need to answer the question clearly. The question says draw the probability distribution. So again we need to draw the table. This time we have to write the correct probabilities for each of them. So that's for 4, this is for 3, and this is for 2, and this is for 1. So x is equal to r 1, 2, 3, and 4, and then probability of x being equal to r is equal to 0.1541, 0.35 it's given, 0.15 we found it out, and then 0.35 is also the same as probability of 2. Okay, right. So all good. So what we wrote here is, let f be the event that the spinner lands on 4. Then f follows binomial distribution 60, 0.35. Then we need to only put these details in our binomial distribution calculator. So we put 60 for the number, 0.35 for the probability, and above 30. Okay, and that probability came to 0.0059, which I put in the calculator to improve the precision. I got 0.00589. Fine. The random variable y is equal to 12 over x. Find probability of y minus x is less than or equal to 4. So here it might look a little bit daunting, but it is just using the algebra. So y is equal to 12 over x. So let's rewrite this. Okay, let me put it as question C. Okay, probability of y less than x being less than or equal to 4 when y is equal to 12 over x. That's a condition, right? We just substitute y is equal to 12 over x in this one. So we have probability of 12 over x minus x, okay, is less than or equal to 4. So this is what we're going to find out. So let's do one thing. Drop the p here and try to simplify this stuff. So 12 over x minus x being less than or equal to 4 is equal to, multiplying everything by x, we get 12 minus x squared is less than or equal to 4x. Bringing them to one side, we get x squared plus 4x minus 12 is greater than or equal to 0. Right? I brought everything to the right. Okay. All right. So now this can simplify by factorizing to x plus, when you multiply, you get minus 12. When you add, you get a 4. So what should that be? It should be x plus 6 bracket x minus 2. Okay, that fits the bill. Is greater than or equal to 0. That means x should be the critical value. We should always write the critical value because x is not equal to minus 6. It is just the critical value is equal to minus 6 or x is equal to 2. But we can straight away reject this saying that x cannot be minus 6. It's the event that somebody is getting some value here. So x is equal to 2. Therefore, you just go back to the table. What's the probability of x being or equal to? So here it is greater than or equal to 0 means I now need to write that x is greater than or equal to 2. So what's the probability of x being greater than or equal to 2? That's what this means. Okay, so that is equal to, look at the probability distribution. 2 is 0.35, 3 is 0.15, 4 is 0.35. Just add the 3. So 0.7 plus 0.15 is 0.85. So you can say 0.35 plus 0.15 plus 0.35 is equal to 0.85. That's it. So we are coming to section mechanics. Unless otherwise indicated, wherever a numerical value of g is required, take g is equal to 9.8 meters per second square and give your answer to 2 significant figures or 3 significant figures. Okay, 6. A man throws a tennis ball into the air so that at the instant when the ball leaves his hand, the ball is 2 meters above the ground and is moving vertically upwards with a speed 9 meters per second. So the best thing is to write as you read, because otherwise we might forget some important information. Let's say this is the level ground. Okay, so this man probably is 2 meters tall. So he is going to throw it. So let's say this is the 2 meter height. Okay, so it's thrown vertically up, the tennis ball. Obviously it will go on a loop and come down and hit the ground. It comes and hits the ground. So what's the speed at which it is thrown? Moving upwards with a speed 9 meters per second. So we can say u is equal to 9 meters per second. All right. Okay. The motion of the ball is modeled as that of a particle moving freely under gravity, and the acceleration due to gravity is modeled as being of constant magnitude of 10 meters per second square. So this g, which is also equal to the a, should be written as minus 10 meters per second square. Why minus? So anything that goes up is termed as positive by us here, and anything that comes down is opposite in direction, that is minus. Okay. The ball hits the ground t seconds after leaving the man's hand. Using the model, find the value of t. So let's document what information is here. So a is equal to minus 10, u is equal to 9, s is equal to, when it hits the ground, it is coming down 2 meters from its original position. So we should say anything going down is minus, right? So minus 2. Okay, the question is asking t is equal to what? Okay, so this is quite easy now. We have got the SUAT equation. So s is equal to ut plus half at square. Just plug the information therein and you'll get the answer. So minus 2, which is s, u is equal to 9 times t, which we don't know, plus half, a is minus 10 and t square. Okay, simplifying, minus 2 is equal to 9t minus 5t square. That means 5t square minus 9t minus 2 is equal to 0. Okay, so how do we factorize and solve this? So when you multiply, you get minus 10. When you add, you get minus 9. So it is 5t square minus 10t plus 1t minus 2 is equal to 0. Factorizing this, 5t goes into the first 2. So you can say t minus 2 plus t minus 2 is equal to 0. That means t should be equal to, see 5t, let's write one more step here. So 5t plus 1 bracket t minus 2 is equal to 0. This actually tells you that t should be equal to minus 1 over 5, which is outright rejected because time cannot be negative, and then t is equal to 2. So the only possible value is time is equal to 2 seconds. That is, this tennis ball comes and lands you on the ground 2 seconds after it was projected from by him. Question 7. A train travels along a straight horizontal track between two stations A and B. In a model of the motion, the train starts from rest at A, that means u is equal to 0, remember, and moves with constant acceleration 0.3 meters per second square for 80 seconds. Cool. The train then moves at constant velocity before it moves with a constant deceleration of 0.5 meters per second square, coming to rest at B. For this model of the motion of the train between A and B, state the value of the constant velocity of the train. Okay, so what we do here is, using the available information, we write a SUVAT equation. So what information do we have? U is equal to 0. We have t is equal to 80 seconds. We have acceleration is equal to 0.3 meters per second square. And the question is asking us the constant velocity is what? That is the constant velocity after it has traveled for 80 seconds. So we can put that into an equation. Which equation is suitable for us to find the velocity from the initial velocity and the time and the acceleration given? It is v is equal to u plus at, right? So v is equal to something which we have to calculate. U, we know it's 0, a 0.3, t is 80. Okay, so that is v is equal to 0.3 times 80, which is 3 8s are 24, 240 with the decimal place. So 24 meters per second because it's velocity. Okay, so I. What's the second part of the question? State the time for which the train is decelerating. Again here, let's document what information we have. Here the u is going to be this 24 meters per second because that's the starting velocity and it ends with velocity being equal to 0, the final velocity. And then we need to find out what t is equal to what, but we know the deceleration. Deceleration is minus something. What is that? 0.5 meters per second square. So here again, we can use the same formula. V is equal to u plus at. Okay, v is 0, u is 24 minus a because it's negative 0.5, and time, we don't know the time. Okay, so we need to therefore write 24 is equal to 0.5 t, which means t is equal to 24 divided by 0.5. So 24 divided by half is actually 24 multiplied by 2, so 48 seconds. The question then asks, sketch out the velocity time graph. So what we do here is, so put the two y and x-axis. Okay, this is time in seconds. Label everything because there is mark for everything. V meters per second. Okay, so it starts from A, goes up with some acceleration, reaches a constant velocity. After that, it runs for some time and then deceleration starts and then it reaches B, at which the velocity will be equal to 0. Okay, so we have to draw an outline like this. Let's say this is the constant velocity and after that the deceleration happens and it reaches here. Okay, so how long was the acceleration? 80 seconds. So this is 80 seconds and this is, we know it's 24 meters per second. Okay, so here we do not know when the deceleration started, but we know the length of the deceleration was 48 seconds. So we can write 48 here. Okay, and this is going to be 0 velocity. Okay, so let's call this as t here. So this is it. So we can say this is the velocity time graph. Right. The total distance between the two stations is 1000. Find the total time taken by the train to travel from A to B. Okay, so we can use the information that the total distance is 4,800 meters because that's going to be the area under velocity time graph. So if you can find the area here, you can put that as an equation and figure out what is t? It seems to be fairly easy here now. So you can say area is equal to distance is equal to 4,800 meters. So what's the area? There is a triangle, there is a rectangle, and there's a triangle. So we can say half base times height, 80 times height is 24. That's the area of the triangle, plus, unfortunately, we do not know the time there. So 24 times t plus, again, half times 48 times 24. This is equal to 4,800. Okay, so this is 40 times 24. Putting this into the calculator, I get 960 plus 24t, plus putting it into the calculator again, I get 576 is equal to 4,800. Okay, making some space here. So 24t is equal to 4,800 minus 960 minus 576. Okay, so that gives me 24t is equal to 3264 as per the calculator, and therefore t is equal to 3264 division 24 is equal to 136 seconds. Okay. So it is not the total time. This is just the time of that constant velocity section, that is the rectangle, right? Therefore, the total time taken is equal to, so the first one was 80 seconds, second one was 136, and the third one is 48, and that's equal to overall 264 seconds. So just one improvement that could be made to the model of the motion of the train from A to B in order to make the model more realistic. Again, this is a model related question at the end, which is a 1 marker. So you need to write one reasonable critique or one reasonable improvement that is possible into the model. So what do you think is possible here? You can actually contextualize this. Here there is a train traveling from A to B 4,800 kilometers, and it says that it goes under constant acceleration, constant deceleration. So that may not be practical all the time. So the model could consider variable acceleration and variable deceleration is a good answer to write. So you can say the model could consider variable acceleration and deceleration. To make it more appropriate and realistic. Fine. Question 8. A particle P moves along the x-axis. At time t seconds where t is greater than or equal to 0, the displacement x meters of P from the origin O is given by this equation, x is equal to. So find the times when P is instantaneously at rest. So what we need to do here is understand that x is the displacement and it's not going to give you the time when it is at rest. We need to convert the displacement equation into an equation for velocity and then put that velocity equation equal to 0, then solve for t. That's the strategy for this. So let's write this equation, x is equal to, and then see what happens after that. So x is equal to half t square bracket t square minus 2t plus 1. So in order to convert this into an equation for velocity, we need to differentiate that because we know that v is equal to dx over dt, where x is the displacement. So in order to differentiate this, the first effort that we need to take is to rewrite this in the form which is differentiable. That is, every term should be written in indices. So x is equal to half t to the power of 4 minus half t square times 2t. So half and 2 will cancel out, and t square becomes t cubed with the t plus half t square. Good. Now put dx by dt is equal to 4 over 2, which is 2 t to the power of 3 when you differentiate it, 3 t square plus 2 over 2, 1 t to the power of 1. Okay, so now we need to put this equal to 0 to find the times at which the velocity is equal to 0. So in AS level and A level, you don't need to learn how to factorize and solve a cubic equation. This is a cubic equation, but you only need to do quadratic equation solving. So how to convert this into a quadratic? So luckily for us, every term contains a t. So you take out one t. So t is out, then 2t square minus 3t plus 1 is equal to 0. All right. Now it's only a matter of factorizing and solving the second part of this equation. So when you multiply, you get 2. When you add, you get minus 3. So that must be 2t square minus 2t minus 1t plus 1 is equal to 0, right? So minus 3t here, and when you multiply minus 2t, minus 2 and minus 1, you get 2. All right. So now factorize this part, t bracket 2t, which is common here, times t minus 1 minus t minus 1 in another bracket, close the bracket again, is equal to 0. Why did I write t minus 1 here? Because there is a minus here. Minus times minus will make it plus, which is what we want here, right? And moreover, this and this should be equal. So this is equal to t bracket 2t. Inside I'm going to factorize now. 2t minus 1 bracket t minus 1 is equal to 0. So here, as it is a cubic, there are 3 roots possible. So the first one is when t is equal to 0. If t is equal to 0, this equation will return a value of 0. So t is 0 is one root. Second part is 2t minus 1 is equal to 0. That means t is equal to half. And then third root is t is equal to 1. That's it. So these are the times at which the velocity will be equal to 0, as well as the particle will be instantaneously at rest. Next part of the question. Find the total distance traveled by p in the time interval 0 to 2. So we need to consider 0 up to 2 and the total distance traveled by this particle. See, since x is the displacement, this function will give you the distance traveled at each time chosen by you. If you put t is equal to 0, you know where it is. If you put t is equal to 1, you will know the new displacement, and finding the difference between them will give you the distance traveled. So our strategy should be to put t is equal to, again, t is equal to 0, half and 1 are the times at which the particle has stopped. So we need to find the distance moved between each stoppage rather. So we can say this is part B, right? So x is equal to, we are going to rewrite that equation. It's half t to the power of 4 minus t cubed plus half t square, right? Okay. So now let's do one thing. When t is equal to 0, what is x? When t is equal to half, what is x? And when t is equal to 1, what is x? And finally, t is equal to 2. Because the question tells you between 0 and 2, what's the total distance traveled? What we have done here is, we have put t is equal to 0, t is equal to half, t is equal to 1, t is equal to 2, and we are working out what is the specific displacement under each of these time values. So for the first one, t is equal to 0, we got 0. For t is equal to half, we are now working out. So this half times 1 over 2 to the power of 4 is 1 over 16 minus 1 over 8 plus 1 over 2 times 1 over 4 is 1 over 8 again. Okay, so that means this and this will cancel. So we have 1 over 32. So let me write, when t is equal to half, distance or displacement is equal to 1 over 32. Okay, that's the position where the particle is. So now we are going to put t is equal to 1. Okay, so therefore x is equal out. When t is equal to 1, half times 1 is half, then minus, okay, it should be 1 here. Okay, and then plus half is overall equal to half, and half is 1. 1 minus 1 is 0. Cool. Now we are going to put t is equal to 2. So let me write here, this is 0. Okay, so when t is equal to 2, x is equal to what? So let's put in t is equal to 2 here. Okay, so half times 2 to the power of 4 is 16. Okay, minus 2 to the power of 3 is 8, plus half 2 to the power of 2 is 4. So overall it's going to be 8, take away 8 plus 2. So it's going to be 2 here. Cool. So now we know the displacements for the different values of t. So t is equal to 0, half and 1 we anyway took because they are the positions, times at which the position has stopped moving. That is, velocity is equal to 0. Right. So now we are also asked by the question to include t is equal to 2. So how to find the distance? Distance is equal to, the distance moved from 0 to 1 over 32 is equal to 1 over 32. Okay, and then plus 1 over 32 to become 0. Again, distance is a scalar quantity 1 over 32, and then plus this is 2. Okay, so that is equal to 1 over 32 plus 1 more over 32 is equal to 2 over 32, plus let's make 2 also as out of 32. So I will put this as 64 here. Okay, 64 divided by 32 is 2. So we have got 66 over 32. So simplifying, I get this as 33 over 16, which is 16 goes into 33 2 times, remainder 1 over 16. So 1 over 16 meters is the total distance moved by the particle between the 2 times that the question asked you.
Okay, next part of the question. Show that P will never move along the negative axis. So we have got this equation x is equal to something. The question asks us why x cannot be negative. So let's write out the equation once again. Half t square times, so spot C. Okay, x is equal to half t square times t square minus 2t plus 1 minus 2t plus 1. Okay. If you closely observe this, you will see that the first part is a square and the second part is t minus 1 is another square, which means this is a combination of two squares, and you know that a square can never be negative. So we can say here half times 2 squares, or you can say just squares, and that's equal to always positive. So x is therefore never negative.
Question 9. So we have got two particles hanging on either side of a pulley. Two small balls P and Q have masses 2m and km respectively, where k is less than 2. Alright, the balls are attached to the ends of a string that passes over a fixed pulley. The system is held at rest with the string tight and the hanging parts of the string vertical as shown in figure 1. The system is released from rest, and in the subsequent motion, P moves downwards with an acceleration of magnitude 5g over 7. The balls are modeled as particles moving freely. The string is modeled as being light and inextensible, the usual wordings. The pulley is modeled as being small and smooth. Using the model, find in terms of m and g the tension in the string. So we need to find the tension in the string, which is going to be the same throughout the string. But how to find out the string tension? So let's do one thing. Since it is a pulley which has got the two particles moving in opposite directions, we can consider the equations separately for P and Q. So let's write for P. So for particle P, okay, so P is moving down, right? Therefore, 2mg, which is the weight, that is 2m times the acceleration due to gravity minus its opposite force is the tension, and 2mg overcomes the tension to move down. So that is equal to its mass, that is 2m times the acceleration. Okay. Now the question already tells you the acceleration is 5g over 7. So we just substitute here so we can find the t. So 2mg minus t is equal to 2m times 5g over 7. Okay. Therefore, bring t to one side and bring everything else to the other. So that is 2mg minus, this is 10mg over 7 is equal to t. Okay, that is 7 times 2, 14. 14 minus 10 is 4mg over 7 is equal to t. Let's look at the next part of the question. Explain why the acceleration of Q also has magnitude 5g over 7. So the question said that acceleration of P is 5g over 7. Now it says explain why acceleration of Q is also having the same magnitude of 5g over 7. That's quite simple. We just need to write that the string is modeled as inextensible. Therefore, the same acceleration will be throughout the system. The string is modeled as inextensible. What it means is it is inelastic. It's not something which is elastic, which will extend and contract, and that will change the acceleration. If it is inextensible, this acceleration will be the same throughout the system. Find the value of k. So k is part of the mass for q. So we need to write the equation for q now. So for q, okay, what's the equation for q? The particle q is moving upwards, right? Therefore, tension is overcoming its weight. So T minus kmg is equal to its mass, which is km, times the acceleration, which we know is 5g over 7. Okay, and T also is known to us because we calculated it. 4mg over 7 minus kmg is equal to km times 5g over 7. Okay, cool. Now what we can do, every item which is common in all the terms can be cancelled off so that our simplification will be easier. See, for example, m is there in all the terms, cancel it out. G is there in all the terms, cancel it out. So now we have got a simpler equation here. 4 over 7 minus k is equal to 5k over 7. All right, that means 4 over 7 is equal to 5k over 7 plus 1k, which is equal to 5k over 7 plus 7k over 7, okay, which is equal to 12k over 7. Okay. Now 4 over 7 is equal to this. Therefore, k should be equal to 4 over 7 times 7 over 12, which is equal to what? 4 over 12 is going to be 1/3. Okay. So underline your answer. Let's go to the next part. As usual, identify one limitation of the model that will affect the accuracy of your answer to part C. Okay, so we found the value of k. So what could be a limitation of the model here? There are many of them, but we need to write only one important one, which is the most common one and a safe one for you to answer is the model considers the balls as particles, but in reality, they may have volume and shape. So the model considers the balls as particles, but in reality they may have size and shape. So that's the end of the paper. Hope this has been quite useful to you. We will see in the next episode of walkthroughs. Bye.